Hello everyone, my name is Akhil Sadiq. I'm a PhD student working with Ullasa Kodandaramaiah at IISER-TVM, India. Here, I will be presenting my poster titled Diversity of Color in the Background Impedes Detection. Animals can employ a diverse array of strategies that help them to hide in plain sight, or in more technical terms, aids them to evade detection and recognition. These strategies are what we call as camouflage. Interestingly, factors besides animal colorations such as water caustics, dappled lighting, or even visual complexity of a background could also impede detection. Studies using humans and trained birds detecting targets on artificial backgrounds have shown that both humans and birds take longer to find targets in a complex background compared to a simple one. However, most of these studies addressing background complexity have used monochromatic backgrounds. But the world is a colorful place, with many backgrounds having multiple hues. So what about colors in background? To address this, we conducted an experiment using trained chicks searching for an artificial prey in the background. We hypothesized that color diversity in background impedes detection. What we mean is that a chick would take longer to find the target in a background with higher color diversity compared to a lower one. Similarly, we hypothesized that luminance diversity in background impedes detection. So to create these backgrounds, we came up with 9 elements distinguishable by the chicks, either in color or in luminance or both. And using these elements, we made 4 background types. A low color diversity, low luminance diversity background, a low color diversity, high luminance diversity background, a high color diversity, low luminance diversity background, and a high color diversity, high luminance diversity background. These backgrounds were printed on A3 size paper, and we used a square piece of paper with random sample of the background as a prey, and the prey was elevated to 2 mm. We used 34 trained chicks for our experiments and found that chicks took longer to detect targets in backgrounds with high color diversity compared to backgrounds with lower color diversity. But since the prey matched the background in this experiment, it is possible that the prey coloration is what affected detection. To test this, we used LCLL and SCLL background as simple and complex backgrounds. And this time we introduced 3 prey types, a simple prey, a complex prey, and a white prey. We used 20 chicks and all chicks underwent 6 combinations of prey and background type. Here we found no effect of prey coloration, and it was once again background color diversity that affected detection time. So it is possible that the contrast between elements were not strong enough to impede detection in case of luminance backgrounds. So we created 5 monochromatic elements, and using these 5 elements, we created a low contrast background, a high contrast background, and a more complex background with all 5 elements. Here too, we did not find any effect of contrast or complexity. So we concluded that color diversity in background affects detection time and luminance diversity does not affect detection time. So if we consider a grasshopper that matches a sand background, they would be better camouflaged in a background with more diversity. So I would like to thank all these wonderful people for helping me out with my work, especially my supervisor, Ullasa Kodandaramaiah, and also Mr. Zacchaeus Pius, who have provided me with all the chicks. And if you're interested to know more about this work, you can check out my paper on the same, published in Behavioral Ecology last year. Thank you.